Hi there, welcome in. I'm so glad you made it here today. Before we get started, I'd love to hear where you're tuning in from and what time it is for you. It's such a treat to see the variety of places and times represented in this community. I also want to gently thank those who have subscribed and clicked like on the videos they enjoy. It really helps this space grow. And of course, if you have ideas for new content, I'd love to hear them in the comments. With that, let's begin. Chapter 1: Understanding Quantum Mechanics Basics. Before the dawn of quantum mechanics, the universe was viewed through the lens of classical physics, where the rules seemed clear and predictable. The grand narratives of Isaac Newton dominated, painting a picture of a clockwork universe governed by deterministic laws. Newton's laws of motion and universal gravitation explained a wide range of phenomena, from the falling of an apple to the orbits of planets. Yet, as scientists peered deeper into the microscopic world, it became increasingly clear that something was amiss. Imagine, if you will, the early 20th century, a time when the very foundations of physics were being challenged. Max Planck, a pivotal figure in this unfolding drama, proposed a revolutionary idea in 1900. He suggested that energy is not emitted continuously, but rather in discrete packets, which he called quanta. This concept laid the groundwork for a new understanding of atomic and subatomic processes. It was a radical departure from classical thought, emphasizing that at the smallest scales, the universe behaves in ways that defy everyday experience. Following Planck, Albert Einstein entered the scene, illuminating the phenomenon of the photoelectric effect in 1905. He proposed that light, long considered a wave, also exhibits particle-like properties. The most beautiful experience we can have is the mysterious, Einstein famously said, and indeed, the mysterious nature of light led to the realization that particles can behave both as waves and as discrete entities. This duality became a cornerstone of quantum theory, challenging the very essence of reality as understood by classical physics. As the scientific community grappled with these new ideas, they were not alone in their struggle. Niels Bohr, another luminary of this era, developed his model of the atom, suggesting that electrons occupy quantized orbits around the nucleus. His work emphasized the importance of experimental evidence in the development of theories. Bohr famously remarked, "An expert is a person who has made all the mistakes that can be made in a very narrow field." This humility in the face of the unknown is a hallmark of the scientific journey. The divergence from classical physics became increasingly pronounced as researchers explored the interactions of particles. Classical mechanics operates under the assumption of determinism, where the future state of a system can be predicted with complete accuracy if its present state is known. However, quantum mechanics introduces a stark contrast through the incorporation of probability. In the quantum realm, particles do not have definite positions or velocities until they are measured. Instead, they exist in a state of probability, described by a wave function that encompasses all potential outcomes. What does this mean for our understanding of the universe? Imagine a particle existing simultaneously in multiple locations until an observation is made. This idea can feel unsettling, yet it emphasizes the nuanced and often counterintuitive nature of quantum mechanics. As physicist Richard Feynman eloquently stated, "If you think you understand quantum mechanics, you don't understand quantum mechanics." The layers of complexity can be daunting, yet they invite us to explore deeper. The role of probability in quantum systems cannot be overstated. Where classical physics relies on certainties, quantum mechanics thrives on uncertainties. A particle's behavior can be described only in terms of probabilities, leading to a framework where outcomes can only be predicted with a degree of likelihood rather than certitude. This probabilistic nature has profound implications, reshaping our understanding of causality and the very nature of reality itself. Consider the thought experiment of a coin. In classical terms, if you flip a coin, it will land either heads or tails. You can predict the outcome based on its initial conditions. Now, imagine that coin as a quantum object, spinning in the air. While it spins, it is not merely heads or tails, it is in a superposition of both states until it lands. This transition from superposition to a definitive state upon measurement encapsulates the essence of quantum mechanics. It suggests that reality itself may be influenced by our observations, weaving together the observer and the observed in a delicate interplay. As we delve into the historical context of quantum mechanics, it is essential to acknowledge the contributions of many outstanding individuals who shaped this field. From the early ideas of Planck to the revolutionary insights of Einstein and Bohr, each step was fraught with challenges and breakthroughs. Their collective efforts paved the way for a deeper understanding of the universe, where the rules of classical physics no longer suffice. In a world governed by quantum mechanics, the interplay of chance and certainty creates a rich landscape for exploration. The principles of quantum mechanics invite us to reconsider not only the nature of matter and energy, but also the very fabric of reality itself. As we ponder these ideas, we are reminded that the universe is not a mere backdrop to our existence, but a vibrant, dynamic entity, teeming with possibilities waiting to be discovered. Let us take a moment to reflect on the profound shift that quantum mechanics represents. It challenges us to embrace uncertainty and complexity, recognizing that the universe is not merely a machine ticking away, but rather a kaleidoscope of potential, where every observation holds the power to influence the outcome. This perspective opens the door to a deeper appreciation of the mysteries that lie at the heart of existence, inviting us to explore the unknown with wonder and curiosity. As we journey further into the realm of quantum mechanics, we will uncover the layers of understanding that have emerged from this field. The transition from classical to quantum thought is not merely a scientific revolution, it is a philosophical awakening. The universe, once seen as a predictable clock, transforms into an intricate symphony of probabilities, inviting us to listen closely to the whispers of the cosmos. The transition from classical physics to quantum mechanics shattered long-held beliefs about the nature of reality. In the classical realm, objects were understood to have definite properties, such as position and momentum, that could be measured with absolute precision. A moving ball, for example, could be tracked in its entirety, its path predicted with unwavering accuracy. However, as we stepped into the world of the very small, everything changed. The behavior of particles at atomic and subatomic scales revealed an astonishingly different reality, one governed by uncertainty and probability. To visualize this shift, imagine a still pond, its surface smooth and unbroken. A stone cast into the water creates ripples, predictable and orderly. When we look at the quantum world, however, it is as if the pond has transformed into a swirling maelstrom, where the ripples become unpredictable waves, constantly changing and morphing. This analogy captures the essence of how classical physics, with its firm foundations, gives way to the fluid and dynamic nature of quantum mechanics. Key figures like Niels Bohr and Werner Heisenberg became pioneers of this new era. Bohr famously stated, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet." His work on the structure of atoms and the nature of light laid the groundwork for understanding quantum phenomena. He proposed that energy is quantized, meaning it can only exist in discrete packets rather than as a continuous flow. This idea was revolutionary, suggesting that at the most fundamental level, the universe operates in a manner that defies our intuitive grasp. As we contemplate the implications of these discoveries, we might ask ourselves, what does it mean for the world around us? The answer lies in the concept of probability, which has become a cornerstone of quantum mechanics. Unlike classical physics, where outcomes can often be predicted with certainty, quantum mechanics introduces a realm of possibilities. When we observe a quantum system, we do not simply measure a pre-existing property. Instead, our observation influences the system itself. This interplay raises profound questions about the nature of reality and the role of the observer. Imagine a coin spinning in the air, a blur of potential states. Is it heads? Is it tails? It is not until we catch it that one outcome is realized, while the other remains in a state of non-existence. This thought experiment encapsulates the essence of quantum superposition, where particles exist in multiple states simultaneously until an observation is made. The act of measurement collapses these possibilities into a single outcome, reshaping our understanding of the universe. Complementing this idea is the principle of wave-particle duality, a concept that illustrates the dual nature of matter. Particles, such as electrons and photons, exhibit both wave-like and particle-like properties depending on how they are observed. This duality was famously captured by physicist Albert Einstein, who remarked, "The most incomprehensible thing about the world is that it is comprehensible." His insights into the nature of light, particularly through the photoelectric effect, demonstrated how light behaves as both a wave and a particle. The implications of this duality challenge our perceptions and compel us to rethink the very essence of existence. The historical context of quantum mechanics also reveals the tensions that arose as these new ideas challenged established scientific norms. Figures like Max Planck, who proposed that energy is quantized, faced skepticism from traditionalists who clung to classical interpretations. Yet, through perseverance and collaboration, these pioneers forged a path toward a new scientific paradigm. Their willingness to embrace the unknown, to step beyond the confines of established thought, paved the way for future discoveries. As we explore further, we encounter the role of probability in quantum systems, a fundamental aspect that distinguishes this field. Probability is not merely a tool for measuring uncertainty. It is entwined with the very fabric of quantum behavior. The probabilistic nature of quantum mechanics leads us to question the deterministic universe envisioned by classical physics. It invites us to consider the intricate web of possibilities that exists within every particle's existence. What might this mean for our understanding of free will and determinism? Can true randomness exist in a universe governed by physical laws? These questions linger, beckoning us to ponder the nature of existence itself. The quantum realm does not merely inform us about the behavior of particles, but also challenges our philosophical constructs, urging us to confront the mysteries that lie beyond our comprehension. The historical narratives of quantum mechanics are rich with stories of conflict and collaboration. As physicists grappled with these new ideas, they often found themselves at odds with one another. The debates between Bohr and Einstein, for instance, illustrated the clash between differing interpretations of quantum mechanics. Bohr's acceptance of uncertainty contrasted sharply with Einstein's insistence on an objective reality, leading to a profound dialogue that would shape the future of physics. These debates remind us that science is not a linear path, but a labyrinth of ideas, where each twist and turn leads to new revelations. Each figure, from Planck to Heisenberg, contributed to a larger understanding, weaving together the intricate strands of quantum theory. Their insights continue to inspire generations of scientists, encouraging them to embrace curiosity and skepticism alike. In this journey through the historical context of quantum mechanics, we find ourselves at the intersection of science and philosophy. The principles we uncover are not merely intellectual exercises. They resonate deeply within our understanding of existence. As we peel back the layers of reality, we begin to see the interconnectedness of all things, revealing a universe that is as much about relationships as it is about particles. As we move forward, let us carry with us the spirit of inquiry that defined the early architects of quantum mechanics. Their courage to question, to explore, and to embrace uncertainty serves as a guiding light in our quest for knowledge. With each revelation, we step closer to understanding the enigmatic dance of the universe, where every particle holds a story waiting to be told. As we reflect on the rich tapestry of ideas woven by pioneers in quantum mechanics, we find ourselves standing on the threshold of a profound philosophical inquiry. The interplay of uncertainty and reality, as highlighted by the debates of the past, sets the stage for the next pivotal moment in our exploration. It was in this climate of intellectual ferment that Erwin Schrödinger introduced his now famous thought experiment, a striking illustration of quantum superposition that would challenge the very foundations of how we understand the microscopic world. As we delve into the story of Schrödinger's cat, we will uncover not only the brilliance of his contributions, but also the initial reactions that sparked further dialogue among scientists. Join me as we embark on this next chapter, where the boundaries of reality and imagination blur, leading us deeper into the mysteries of quantum theory. Chapter 2: The Birth of Schrödinger's Cat Thought Experiment. In the realm of quantum mechanics, few concepts evoke as much intrigue and curiosity as the famous thought experiment known as Schrödinger's cat. Imagine a closed box, a cat inside, along with a radioactive atom, a Geiger counter, and a vial of poison. The fate of the cat hinges on the unpredictable behavior of the atom, embodying the essence of quantum superposition. Is the cat alive or dead? In this enigmatic scenario, the cat exists in a state of both life and death until someone opens the box to observe it. This paradox not only captivates the imagination, but also serves as a poignant illustration of the complexities inherent in quantum theory. The origins of this thought experiment can be traced back to the mind of Erwin Schrödinger, an Austrian physicist whose contributions to quantum theory were profound and far-reaching. Born in 1887, Schrödinger was a pioneering figure in the development of wave mechanics, a formulation of quantum mechanics that emphasized the wave-like nature of particles. He introduced the wave equation, a fundamental equation in physics that describes how quantum states evolve over time. Schrödinger's work laid the groundwork for much of modern quantum theory, earning him recognition as one of the leading scientists of his time. In 1935, amidst the burgeoning exploration of quantum mechanics, Schrödinger formulated his cat paradox as a means to illustrate the peculiar concept of quantum superposition. At a time when the quantum world was becoming increasingly understood, he sought to highlight the absurdity of applying quantum principles to everyday objects. Schrödinger believed that the mathematical formulations of quantum mechanics, while elegant, led to nonsensical conclusions when extended beyond the microcosm of subatomic particles. He famously stated, "I do not like it, and I want to know what it is." The cat paradox became a powerful tool for critiquing the interpretations of quantum mechanics prevalent at the time. The purpose of this thought experiment was not merely to provoke thought, but to challenge the prevailing notions of reality and observation in the quantum realm. The idea of the cat existing in a dual state of life and death until observed raises profound questions. What does it mean to observe something? How does observation affect reality? These inquiries invite us to imagine a world where the act of measurement plays a crucial role in determining outcomes. Schrödinger's cat dares us to confront the unsettling implications of quantum mechanics, while simultaneously prompting reflection on the nature of existence itself. When Schrödinger first unveiled this paradox, the reactions from the scientific community were varied. Some embraced it as a thought-provoking exercise that illuminated the complexities of quantum mechanics. Others, however, dismissed it as an impractical and overly dramatic illustration. Albert Einstein, a contemporary of Schrödinger, famously responded to the paradox by stating, "God does not play dice with the universe," expressing his discomfort with the randomness and uncertainty that quantum mechanics proposed. This dialogue between Schrödinger and Einstein exemplifies the broader debate within the scientific community regarding the interpretation of quantum theory. As the years unfolded, Schrödinger's cat evolved into a cornerstone of discussions surrounding quantum mechanics. It transcended its original purpose, becoming a cultural reference point that sparked curiosity and debate far beyond the confines of academia. The paradox invites listeners to imagine the box, the cat, and the uncertainty that envelops the entire scenario. Can you feel the tension in the air as you ponder the fate of that little creature inside? This thought experiment has not only shaped scientific discourse, but also inspired artists, writers, and philosophers to engage with the profound questions it raises. In a world increasingly influenced by the principles of quantum mechanics, the legacy of Schrödinger's cat endures. It serves as a reminder of the mysteries that lie beneath the surface of reality and the delicate interplay between observation and existence. The paradox remains a vital part of our understanding of the quantum world, urging us to explore the depths of our own perceptions and assumptions. As we delve deeper into the nature of reality, let us consider the implications of a universe that exists in states of possibility, where each observation brings forth new understandings and revelations. The journey into the heart of quantum mechanics has only just begun, and with it, the tantalizing allure of Schrödinger's cat continues to beckon us forward. The cat paradox invites us to ponder the essence of reality itself. Imagine a world where particles exist in a state of superposition, a realm where they can be in multiple states at once until an observation collapses those possibilities into a single outcome. Schrödinger's thought experiment elegantly illustrates this concept, asking us to visualize a scenario in which a cat, sealed within a box, is simultaneously alive and dead, existing in both states until we dare to peek inside. This idea, conceived in 1935, was not merely a whimsical musing from a brilliant mind. It served as a critical commentary on the Copenhagen interpretation of quantum mechanics, which posits that particles do not have definite properties until measured. Schrödinger aimed to demonstrate the absurdity of applying quantum mechanics to macroscopic objects, like a cat, to highlight the perplexities that arise when we attempt to reconcile the quantum realm with our everyday experiences. Schrödinger's contributions to quantum theory extend far beyond this singular thought experiment. His work on wave mechanics and the formulation of the Schrödinger equation laid the groundwork for modern quantum physics. This equation describes how the quantum state of a physical system evolves over time, encapsulating the fundamental principles of wave-particle duality. Schrödinger once remarked, "I do not like to be thought of as a physicist. I see myself more as a philosopher." His insights reflect a profound understanding that the boundaries of science and philosophy often blur when grappling with the nature of existence. As we delve into the scientific community's initial reactions to the cat paradox, we find a mixture of intrigue and skepticism. Some physicists embrace the thought experiment as a thought-provoking challenge to established notions, while others dismissed it as a fanciful distraction. Niels Bohr, a key figure in the development of quantum mechanics, engaged in spirited debates with Schrödinger. Bohr argued for the probabilistic nature of quantum events, emphasizing that the act of measurement plays a crucial role in determining outcomes. He believed that the uncertainty inherent in quantum mechanics should be embraced rather than resisted. The dialogue between these scientific giants encapsulates the heart of the quantum debate. Can you imagine the atmosphere in those discussions, filled with passionate arguments and profound insights? The tension between Schrödinger's deterministic inclinations and Bohr's acceptance of uncertainty sparked discussions that resonate through the corridors of physics to this day. As we explore the implications of Schrödinger's cat, we begin to realize that this thought experiment transcends mere theoretical musings. It raises profound questions about the nature of reality, existence, and observation. What does it mean for something to exist in a state of potentiality? How does our act of observation shape the universe around us? Visualize the cat in the box, the vial of poison, the Geiger counter ticking away in the background. The cat's fate hinges on a quantum event, an atom's decay that may or may not occur. The tantalizing uncertainty forces us to confront our assumptions about reality. As physicist Richard Feynman once said, "The imagination of nature is far greater than the imagination of man." This sentiment echoes through the layers of quantum mechanics, inviting us to embrace the unknown. As the scientific community grappled with the implications of Schrödinger's cat, the paradox began to seep into popular culture, influencing literature, art, and philosophy. The imagery of the cat in a state of limbo captured the imagination of many, becoming a symbol of uncertainty and the complexities of existence. Authors and filmmakers embraced the theme, weaving it into narratives that challenge our understanding of reality. Consider how the cat has been depicted in various artistic forms. Artists have painted the cat as a ghostly figure, suspended between life and death, embodying the very essence of quantum superposition. In literature, the concept has inspired stories where characters grapple with the dualities of their existence, mirroring the cat's fate inside the box. The metaphor resonates deeply, inviting us to reflect on our own lives and the choices that shape our realities. While Schrödinger's cat was intended to highlight the peculiarities of quantum mechanics, it also serves as a reminder of the limitations of classical thinking. In our everyday experiences, we tend to gravitate towards certainty, seeking clear answers and definitive outcomes. Yet, the paradox urges us to confront the gray areas of existence, where possibilities intertwine and the unknown lurks around every corner. Imagine standing at the edge of a vast forest, where each path represents a different choice, a different outcome. The cat in the box embodies this very essence, reminding us that our decisions, or the lack thereof, can lead to multiple realities. This metaphor extends beyond the realm of physics and seeps into philosophy, ethics, and even personal reflections, challenging us to embrace the complexities of our choices. As we journey deeper into the realms of quantum mechanics, the cat paradox stands as a beacon, illuminating the intricate web of possibilities that constitutes our universe. It encourages us to remain curious, to explore the questions that arise from uncertainty, and to embrace the mysteries that lie within. In this exploration, we find ourselves asking, what is the nature of existence? Are we merely observers, or do we actively shape the realities around us? Each inquiry leads us to a deeper understanding of the universe, as we strive to grasp the elusive concepts that govern the quantum world. The legacy of Schrödinger's cat continues to inspire researchers and thinkers alike. As experimental techniques advance, scientists have begun to explore the boundaries of quantum superposition in ways that were once thought impossible. The cat has become a touchstone for discussions about quantum computing, entanglement, and the very fabric of reality itself. Imagine a future where the principles of quantum mechanics are harnessed to create technologies that transcend our current understanding. In this future, the mysteries of Schrödinger's cat may guide us toward breakthroughs that revolutionize the way we perceive the universe. As we reflect on the cat's place in the annals of science, we recognize that its significance extends far beyond a mere thought experiment. It is a profound invitation to engage with the mysteries of existence, to ponder the nature of reality, and to explore the intricate dance between observation and the observed. The journey into the world of quantum mechanics is far from over. With each discovery, we peel back the layers of understanding, revealing the intricate connections that bind us to the cosmos. Schrödinger's cat remains a pivotal figure in this ongoing narrative, urging us to confront the elegant complexity of our universe and to embrace the uncertainties that accompany our quest for knowledge. As we step forth into this exploration, let us carry with us the spirit of inquiry embodied by Schrödinger and his contemporaries. The cat, alive and dead within its box, invites us to delve deeper into the heart of quantum mechanics, challenging us to redefine our perceptions and embrace the wondrous possibilities that lie ahead. As we stand at this pivotal juncture, the enigmatic nature of Schrödinger's cat invites us into the heart of quantum mechanics, where the concept of superposition awaits our exploration. This state of being, where particles exist in multiple forms simultaneously, challenges our understanding of reality and prompts us to reconsider the very act of observation. With each layer we uncover, we move closer to grasping the delicate interplay between existence and perception. In the next chapter, we will delve into the intricacies of quantum superposition, examining its profound implications and real-world manifestations, as we continue our journey into the fascinating realm of the unseen. Chapter 3: Exploring Quantum Superposition. Imagine a box, closed tightly, in which lies a cat. This is not an ordinary cat, but one that resides in a peculiar state. If you have heard of Schrödinger's thought experiment, you might already know that this cat is both alive and dead at the same time, an embodiment of a concept known as superposition. This paradox, proposed by physicist Erwin Schrödinger in 1935, serves as a gateway into the world of quantum mechanics, allowing us to explore the strange and fascinating nature of reality. Superposition in quantum mechanics suggests that particles can exist in multiple states at once until an observation is made. This means that until we measure or observe a quantum system, it can be both here and there, both spinning clockwise and counterclockwise, both existing and not existing in a defined state. This phenomenon is not just a theoretical curiosity, it is a fundamental principle that governs the behavior of particles at the quantum level. Imagine a particle that could be simultaneously in two locations, each representing different possibilities. The very act of observing the particle forces it to choose a position, collapsing this superposition into a singular reality. To visualize this, think of a wave in the ocean. Before it breaks upon the shore, it is a fluid and ever-changing form, a mix of energies and possibilities. It is only when it crashes against the rocks that it takes on a definitive shape, a specific outcome. In quantum mechanics, this breaking of the wave function is akin to what happens when we observe a particle. As physicist Niels Bohr famously stated, we are not talking about the world of our experience, but about the world of our imagination. The world of quantum mechanics is indeed a realm where imagination meets reality. Superposition isn't confined merely to thought experiments. It appears in real-world scenarios as well. Take, for example, the behavior of electrons. Electrons can be in multiple energy states at once, a characteristic that forms the basis for technologies such as lasers and transistors, which underpin much of modern electronics. In superconductors, electrons can flow without resistance, existing in a superposition of energy states that allows them to move freely. This ability to exist in multiple states has enormous implications for the development of quantum computing, where qubits, the building blocks of quantum information, can represent both 0 and 1 simultaneously. As we delve deeper into the implications of superposition, we encounter the pivotal role of observation. The moment we attempt to measure a quantum state, the superposition collapses into a definite state. This phenomenon raises profound questions about reality itself. What does it mean for something to exist only when we observe it? The implications ripple across the fabric of our understanding. Albert Einstein, who famously resisted the idea that God does not play dice with the universe, questioned the randomness introduced by quantum mechanics, suggesting instead that a deeper reality lay hidden beneath these strange behaviors. Imagine standing at the edge of a vast forest, where the trees represent the different states a particle can inhabit. As you step forward to observe them, the forest changes, revealing a single path. This analogy captures the essence of how observation affects quantum systems. It forces a resolution of possibilities, highlighting the delicate interplay between the observer and the observed. The act of measurement transforms potential into actuality, reshaping our understanding of existence. This interplay between observation and reality begs the question: is reality something that exists independently of our perception? Or is it a construct shaped by our interactions with the quantum world? The answers are as elusive as the particles themselves, leading to varying interpretations of quantum mechanics. Some scholars embrace the Copenhagen interpretation, which posits that quantum systems exist in superposition until measured. Others advocate for the many worlds interpretation, suggesting that all possible outcomes occur in separate, branching realities, creating a multiverse of infinite possibilities. The implications of superposition and observation extend far beyond abstract theories. They challenge our fundamental understanding of measurement and reality, prompting us to reconsider what we know about existence itself. As physicist Richard Feynman eloquently put it, the imagination of nature is greater than the imagination of man. This notion resonates deeply within the realm of quantum mechanics, where the universe operates in ways that often defy our intuitive understanding. As we continue to explore the intricacies of superposition, we find that it is not merely a scientific concept, but a lens through which we can view the universe. It invites us to ponder the nature of reality, the role of the observer, and the connection between thought and existence. Each exploration of quantum superposition deepens our appreciation for the mysteries that lie within the subatomic world and challenges us to embrace the unknown. The beauty of quantum superposition lies in its ability to inspire curiosity and wonder. It opens doors to new possibilities, encouraging us to ask questions and seek deeper understanding. As we stand at the threshold of this quantum frontier, we are reminded that the universe is a vast and intricate web of connections, each thread woven together by the forces of nature. And at the heart of this web lies the profound realization that our perceptions shape the very fabric of reality itself. The thought experiment of Schrödinger's cat serves as a striking illustration of superposition, inviting us into a world where possibilities coexist until the moment of observation. Imagine, if you will, a a cat inside a sealed box with a mechanism that has a 50% chance of releasing a poison gas. Until we open the box, the cat exists in a dual state, both alive and dead simultaneously. This paradox not only captures the essence of superposition, but also challenges our understanding of life and death, existence and non-existence. As Schrödinger himself noted, a cat may be considered as both alive and dead, depending on whether we observe it or not. Superposition in quantum mechanics is not confined to whimsical thought experiments. It is a fundamental principle that governs the behavior of particles at the microscopic level. When we delve into the quantum realm, we discover that particles can exist in multiple states at once. A single electron, for example, does not have a definitive position or momentum until measured. Instead, it occupies a cloud of probabilities, each representing a potential outcome. This enigmatic behavior is beautifully encapsulated in the idea that particles exist in a state of superposition, embodying various possibilities until an observation collapses them into a single reality. Consider the behavior of light, which offers another fascinating glimpse into superposition. Photons, the fundamental particles of light, can also be in states of superposition. They can travel through multiple paths simultaneously, as demonstrated in the famous double-slit experiment. When light passes through two closely spaced slits, it creates an interference pattern, as if the photons behaved like waves overlapping in space. Only when we observe which slit the photon passes through does the interference pattern disappear, and the light behaves as a particle. This observation collapses the superposition, forcing the photon into a single state. What does this tell us about the nature of reality? Could it be that the very act of observing influences the behavior of the universe itself? The implications of quantum superposition extend far beyond just particles and photons. They resonate deeply in our understanding of the cosmos. Take, for instance, the behavior of atoms in a superposition state. At the quantum level, atoms can exist in multiple energy states at once, a phenomenon that is pivotal in technologies like magnetic resonance imaging. This ability to be in superposition enables atoms to absorb and emit energy in a way that classical particles cannot. As we explore these intricate behaviors, we are drawn into a realm where the lines between reality and possibility blur, and the universe reveals itself as an intricate dance of probabilities. Furthermore, the role of observation in quantum mechanics cannot be overstated. The act of measuring a quantum system fundamentally alters its state. This phenomenon is known as wave function collapse, where a superposition of possibilities collapses into a single outcome upon observation. It raises profound questions about the nature of reality. Does the universe exist independently of our observation, or is it intrinsically linked to our consciousness? The philosopher and physicist David Bohm once remarked, "The observer is an integral part of the observed." This perspective invites us to reflect on our connection to the universe and our role as conscious participants in its unfolding. As we ponder these concepts, it is essential to consider the implications of quantum superposition on our understanding of reality. If our observations influence the outcome of quantum events, what does that imply about the nature of existence itself? Are we mere spectators in a grand cosmic play, or do we actively shape the narrative of the universe? These questions propel us into the depths of philosophical inquiry, where science and metaphysics converge. In practical terms, the implications of superposition are already manifesting in technological advancements. Quantum computing, for example, leverages superposition to perform calculations at speeds unattainable by classical computers. By utilizing qubits, quantum bits that can exist in a state of superposition, quantum computers can process vast amounts of information simultaneously. This capability holds the potential to revolutionize fields such as cryptography, materials science, and drug discovery. As we stand on the brink of this technological revolution, we are reminded that the principles of quantum mechanics are not confined to the theoretical realm. They have tangible effects on our daily lives. Imagine a future where quantum technologies enhance our understanding of the universe and our place within it. As we unlock the secrets of quantum superposition, we may uncover new insights into the very fabric of reality. The journey into the quantum realm is not merely an exploration of particles and waves. It is an invitation to expand our consciousness and embrace the mysteries that lie ahead. Each discovery becomes a stepping stone, illuminating the shadows of uncertainty that envelop our understanding of existence. As we delve deeper, we come to appreciate the elegance of quantum superposition and its intricate dance with observation. Every experiment, every observation, adds another brushstroke to the canvas of our understanding. The universe is not a static entity. It is a dynamic interplay of possibilities, shaped and reshaped by the act of measurement. As physicist Niels Bohr famously stated, we must be clear that when it comes to atoms, language can be used only as in poetry. In this poetic interpretation of quantum reality, we find ourselves in a landscape where the familiar laws of classical physics give way to a more nuanced understanding of existence. The relationship between observation and reality invites us to reconsider our perspectives. If our consciousness plays a role in shaping the universe, how might that change the way we interact with the world around us? Are our thoughts and intentions more powerful than we have been led to believe? These questions echo through the corridors of scientific inquiry, urging us to remain open to new possibilities and interpretations. As we continue to explore the enigmatic world of quantum superposition, we are reminded that the journey is as important as the destination. Each step leads us closer to unlocking the secrets of the universe, revealing a reality that is far more complex and beautiful than we could have ever imagined. It is a reminder that the act of exploration, both within and without, is a fundamental part of the human experience, inviting us to embrace the unknown with curiosity and wonder. The universe, in all its intricate glory, awaits our discovery. As we reflect on the profound implications of quantum superposition, it becomes clear that our journey through the quantum realm is just beginning. The dance of possibilities not only reshapes our understanding of reality, but also prepares us to encounter another cornerstone of quantum mechanics: entanglement. This intricate phenomenon, where particles become interconnected in ways that defy classical intuition, beckons us to explore its significance and the mysteries it holds. With each revelation, we inch closer to understanding the very fabric of our universe, where the threads of reality weave together in unexpected ways. Join us as we delve into the fascinating world of quantum entanglement, where the boundaries of space and time blur, and the implications for information transfer challenge our perceptions of connectivity and existence. Chapter 4: Delving into Quantum Entanglement. In the realm of quantum mechanics, few ideas challenge our understanding of reality more profoundly than Schrödinger's cat. This thought experiment, conceived by Erwin Schrödinger in the early 20th century, encapsulates the strange nature of quantum systems. It raises questions about the very fabric of existence, pushing the boundaries of classical physics. Imagine a cat inside a sealed box, simultaneously alive and dead, until an observer opens the box. This paradox not only illustrates the concept of superposition, but also leads us to the perplexing phenomenon of quantum entanglement. Quantum entanglement is a fundamental aspect of quantum mechanics, where two or more particles become interconnected in such a way that the state of one particle instantaneously influences the state of another, regardless of the distance separating them. This peculiar relationship defies our classical intuitions about locality and causality. Einstein famously referred to it as spooky action at a distance, expressing his discomfort with the implications of entangled particles. Yet, entanglement is not merely a curiosity. It serves as a cornerstone for emerging technologies such as quantum computing and quantum cryptography. The significance of quantum entanglement extends beyond theoretical musings. It has been demonstrated through a series of famous experiments that confirm its existence and properties. One such experiment, conducted by Elaine Aspect in the 1980s, involved measurements of polarized photons. When these entangled photons were sent in opposite directions, their states were found to be correlated in ways that classical physics could not explain. This experiment validated the predictions of quantum mechanics and challenged the classical view of separate, independent particles. As we delve deeper into the relationship between entanglement and Schrödinger's cat, we begin to see how these concepts intertwine. The cat thought experiment illustrates a fundamental principle of quantum mechanics. That observation plays a crucial role in determining the state of a system. In the case of entangled particles, the act of measuring one particle affects the state of the other, even if they are light years apart. This leads us to ponder: how does information transfer occur in entangled systems? The paradox of information transfer in entangled systems raises fascinating questions about the nature of reality. When a measurement is made on one particle, the outcome seems to instantaneously affect its entangled partner. Yet, this transfer of information does not allow for faster-than-light communication, as it requires classical channels to compare the results of the measurements. This peculiar interplay between entanglement and information leads to a deeper understanding of the universe, one that defies our conventional notions of space and time. Consider the implications of entangled particles in everyday life. Imagine two entangled particles separated by vast distances, yet their fates are inexorably linked. The very act of observing one particle collapses its wave function, determining its state, while simultaneously influencing the other. This phenomenon invites us to reflect on the interconnectedness of all things in the universe. Are we not all, in some way, entangled? As physicist John Bell articulated, if quantum mechanics is right, then it seems that the world is a very strange place. His work set the stage for exploring the implications of entanglement, leading to what we now refer to as Bell's theorem. This theorem establishes that no local hidden variable theory can reproduce all the predictions of quantum mechanics, reinforcing the idea that entanglement is indeed a fundamental feature of nature. In our exploration of quantum entanglement, we also encounter the mind-bending concept of superposition. When particles are entangled, they can exist in a superposition of states until a measurement is made. This duality is at the heart of Schrödinger's cat, where the cat is both alive and dead until observed. The entangled state of particles mirrors this superposition, showcasing the profound mysteries hidden within the quantum world. The implications of entanglement stretch far beyond theoretical physics. As researchers continue to investigate these phenomena, they are uncovering practical applications that could revolutionize technology. Quantum computers, for instance, leverage the power of entanglement to perform calculations at speeds unimaginable with classical computers. In the realm of communication, quantum key distribution utilizes the principles of entanglement to create secure channels that are virtually immune to eavesdropping. Yet, as we marvel at these advancements, we must also confront the philosophical questions that entanglement raises. What does it mean for our understanding of reality if two particles can instantaneously affect one another across vast distances? How do we reconcile this with our everyday experiences? These inquiries echo the sentiments of physicist Niels Bohr, who stated, "We must be careful not to confuse the world as we have it with the world as it is." As we immerse ourselves in the wonders of quantum entanglement, we invite you to imagine the intricacies of a universe that operates on principles we are only beginning to grasp. Visualize a cosmic web with particles and waves intertwining, their fates intertwined in a dance of probability and uncertainty. Feel the soothing embrace of the mysteries that lie at the heart of existence, a reminder that not everything is as it seems. As we journey through this captivating landscape of quantum entanglement, we are reminded of the words of physicist Richard Feynman, who famously proclaimed, "The imagination of nature is far, far greater than the imagination of man." Indeed, as we delve deeper into the quantum realm, we find ourselves standing on the precipice of understanding, gazing into a world that challenges our perceptions and invites us to reconsider the very nature of reality. In this exploration, we are not merely passive observers. We are participants in a grand experiment, each of us contributing to the unfolding narrative of the universe. As we ponder the intricacies of entangled systems, we find ourselves asking, what does it mean to be connected? What truths lie hidden within the fabric of existence? These questions linger in the air, waiting to be explored further. As we continue to peel back the layers of quantum entanglement, we discover a world rich with possibilities, a realm where the boundaries of time and space blur, and where the ordinary becomes extraordinary. The beauty of entanglement lies not only in its scientific implications, but also in its ability to inspire wonder and curiosity, inviting us to embrace the unknown and seek answers to life's most profound mysteries. The concept of quantum entanglement, where particles become intertwined in ways that defy classical understanding, has captivated the minds of scientists and philosophers alike. Imagine two particles, once part of the same entity, separated by vast distances. Despite their separation, a change in the state of one instantaneously affects the state of the other. It is as though they possess a secret language, a connection that transcends the barriers of space. This phenomenon challenges the classical notion of locality, where objects are thought to be influenced only by their immediate surroundings. Consider the famous thought experiment involving Schrödinger's cat once more. This time, envision the cat not merely as a paradox, but as a metaphor for entangled systems. When we place the cat in a box with a radioactive atom, its fate becomes entangled with that atom. The cat exists in a state of superposition, alive and dead, until an observer opens the box and collapses that superposition into one definitive state. In doing so, we are not merely observing, we are participating in the very act of defining reality. As physicist Albert Einstein once remarked, reality is merely an illusion, albeit a very persistent one. One of the most striking demonstrations of quantum entanglement is often referred to as the Bell test experiments, named after physicist John Bell. These experiments aim to show whether the predictions of quantum mechanics hold true against classical theories of local hidden variables. Envision a scenario where two entangled particles are sent to opposite ends of a laboratory. Upon measuring one particle, the other instantaneously responds, as if it knows what has happened. The correlations observed in such experiments consistently align with quantum predictions, raising profound questions about the nature of reality and the interconnectedness of the universe. Imagine the implications of this phenomenon on a larger scale. If particles can remain connected across vast distances, could this suggest that the universe itself is a vast, interconnected web of existence? Could it be that the fabric of reality is woven from the threads of entangled relationships? These speculations spark a sense of wonder, inviting us to explore the very essence of our universe. As we delve deeper, we encounter the paradox of information transfer in entangled systems. How is it possible for information to be shared instantaneously between particles separated by light years? This question lingers in the minds of scientists, prompting debates about the very nature of communication in the quantum realm. It is important to note that while entanglement does allow for correlations between distant particles, it does not permit the transmission of information faster than the speed of light. This nuance is essential, yet it does not diminish the profound implications of entanglement on our understanding of space and time. Imagine a future where the principles of quantum entanglement are harnessed to develop revolutionary technologies. Quantum computing, for instance, relies heavily on the principles of superposition and entanglement to perform calculations at speeds unimaginable with classical computers. Picture a world where complex problems, from cryptography to drug discovery, are solved in mere moments, all thanks to the interconnected nature of quantum particles. Furthermore, entanglement has applications in quantum communication, promising secure transmission of information that is fundamentally protected from eavesdropping. As physicist Charles Bennett expressed, quantum cryptography is the first technology that allows two parties to detect the presence of an eavesdropper. Such advancements not only challenge our understanding of technology, but also redefine our relationship with information itself. As we reflect on these concepts, the intertwining of science and philosophy becomes evident. The questions raised by quantum entanglement extend beyond the realm of physics, urging us to ponder our own interconnectedness as human beings. Just as particles can become entangled, so too can our lives be woven together through shared experiences and relationships. What does it mean to be entangled in the fabric of existence? How do our actions ripple through the web of life, affecting those around us in ways we may not fully understand? In contemplating these ideas, we find ourselves drawn into a contemplative space where science meets spirituality. The ancient wisdom of interconnectedness resonates with the findings of modern physics, suggesting that the universe is not a collection of isolated entities, but a symphony of interactions. This perspective encourages us to embrace empathy and compassion, recognizing that our choices impact the larger tapestry of life. As we journey through this exploration of quantum entanglement, we are reminded of the delicate balance between certainty and uncertainty. The quantum world invites us to release our grips on rigid definitions and embrace the fluidity of existence. In this realm, the known and unknown intertwine, revealing a landscape rich with possibilities. The legacy of quantum entanglement echoes through the words of those who have dared to question the nature of reality. As physicist Niels Bohr aptly stated, the opposite of a fact is falsehood, but the opposite of a profound truth may very well be another profound truth. This duality invites us to hold space for multiple perspectives, to explore the paradoxical nature of existence, and to remain open to the mysteries that lie ahead. In this ever-expanding universe, the journey into quantum entanglement is not merely an academic pursuit. It is an invitation to delve into the heart of existence, to ponder the profound connections that bind us all, and to embrace the unknown with open hearts and curious minds. As we continue this exploration, we find ourselves on a path where the boundaries of science, philosophy, and the human experience converge, leading us to a deeper understanding of our place within the cosmos. As we navigate the intricate tapestry of quantum entanglement, we are compelled to confront the profound implications that arise at the intersection of science and philosophy. The questions of interconnectedness and the nature of existence lead us naturally to the enigmatic thought experiment of Schrödinger's cat, which challenges our perceptions of measurement and reality. In the realm of quantum mechanics, where observation shapes outcomes, we must consider how these principles extend into the fabric of consciousness itself. With each layer we peel back, we uncover a deeper understanding of not only the universe, but also our role within it. Join me as we delve into the philosophical ramifications of Schrödinger's cat, exploring the varied interpretations that continue to spark debate and inspire inquiry. Chapter 5: Philosophical Implications of Schrödinger's cat. In the realm of quantum mechanics, the act of observation takes on a profound significance, reshaping our understanding of reality itself. At its core, the role of observation is not simply about witnessing an event. It is intricately tied to the very fabric of existence. Imagine a world where the mere act of looking transforms possibilities into certainties. When we observe a quantum system, we do not merely gain information. We actively influence the outcome of that system. This phenomenon, often referred to as the observer effect, reveals that reality is not a fixed entity, but rather a fluid interplay between observation and existence. The philosophical debate surrounding measurement and reality invites us to contemplate the nature of our universe. What does it mean for something to exist if it is contingent upon observation? This question has sparked intense discussions among philosophers and physicists alike. Some argue that reality is independent of our perceptions, while others contend that it is inextricably linked to the act of observation. The implications of this debate extend far beyond the boundaries of physics, challenging our fundamental understanding of existence itself. As we delve deeper into the interpretations of quantum mechanics, two prominent schools of thought emerge: the Copenhagen interpretation and the many worlds interpretation. The Copenhagen interpretation, championed by figures like Niels Bohr, posits that quantum particles exist in a state of superposition until measured. In this view, reality remains probabilistic, with outcomes determined only when an observation occurs. Conversely, the many worlds interpretation, proposed by Hugh Everett, suggests that every possible outcome of a quantum event creates a branching of realities. Imagine a multiverse, where every decision and every observation spawns an entirely new universe, each containing its own distinct version of reality. This interpretation challenges our conventional notions of existence and raises questions about the nature of choice and fate. The implications of the observer effect extend beyond the realm of physics and into the realm of consciousness. As we consider the role of observation in quantum mechanics, we must also ponder how our conscious awareness interacts with the universe. Does consciousness play a fundamental role in shaping reality? In the words of physicist Wolfgang Pauli, the unconscious does not only influence the conscious mind, but also shapes the external world. This perspective invites us to reflect on the interconnectedness of mind and matter, suggesting that our awareness may have profound implications for the very nature of existence. Schrödinger's cat, with its paradoxical predicament, serves as a focal point in this philosophical discourse. The thought experiment illustrates the complexities of superposition and the role of observation in determining reality. The cat, simultaneously alive and dead until observed, challenges our intuitive understanding of life and death. It beckons us to confront the uncertainties that permeate our existence. In a way, the cat embodies the very essence of quantum mechanics, a realm where certainty gives way to probability, and where the act of observation becomes a defining moment. As we ponder the philosophical implications of Schrödinger's cat, we are invited to explore the boundaries of our understanding. What does it mean to be alive, and how do we define existence? These questions echo through the halls of philosophy and science alike, urging us to examine the nature of reality from multiple perspectives. The cat's plight compels us to consider the interplay between observer and observed, and how this relationship shapes our comprehension of the universe. In the exploration of these themes, we find ourselves at a crossroads of science and philosophy, where the inquiry transcends disciplinary boundaries. The implications of observation in quantum mechanics challenge us to rethink our assumptions about reality and our place within it. As we engage with these profound questions, we are reminded of the words of physicist Albert Einstein, who famously remarked, "The most incomprehensible thing about the universe is that it is comprehensible." In this vast expanse of thought, we are encouraged to imagine a world where our perceptions hold the power to shape reality. As we ponder the role of observation, we might ask ourselves, how do our beliefs and expectations influence the world around us? What if our thoughts could manifest tangible changes in our experiences? The philosophical implications of these inquiries are as vast as the universe itself, inviting us to explore the depths of our consciousness and the mysteries of existence. As we continue to unravel the intricacies of quantum mechanics, we find that the discussion surrounding Schrödinger's cat serves as a catalyst for deeper exploration. The thought experiment not only reveals the peculiarities of quantum phenomena, but also invites us to reflect on our understanding of life, death, and the nature of reality. It encourages us to ask questions that probe the very foundation of our beliefs and perceptions. In this ongoing dialogue between science and philosophy, the role of observation becomes a bridge that connects disparate realms of thought. The act of witnessing, of engaging with the world around us, takes on a sacred quality, as if we are participants in a grand cosmic play. This perspective invites us to view ourselves not merely as passive observers, but as active creators of our reality, shaping the world with every intention and thought. Schrödinger's cat continues to resonate within philosophical discourse, serving as a reminder of the complexities and mysteries that pervade our understanding of life. The cat's dual existence encapsulates the essence of uncertainty and invites us to embrace the unknown. It compels us to consider the implications of our choices and the reality we construct through our perceptions. As we reflect on the philosophical implications of the observer effect and the interpretations of quantum mechanics, we are reminded of the profound interconnectedness of all things. The universe, in its infinite complexity, invites us to explore the boundaries of our understanding and to question the very nature of reality itself. In this pursuit, we may find solace in the knowledge that our inquiries, no matter how daunting, are part of a larger tapestry of exploration, one that weaves together science, philosophy, and the essence of being. In contemplating these ideas, we may feel a sense of peace wash over us, as if we are cradled in the embrace of the cosmos. The mysteries of existence may remain elusive, but in our quest for understanding, we discover the beauty of curiosity and the joy of exploration. Each question leads us deeper into the heart of the unknown, igniting our imagination and inspiring us to seek answers that resonate with the soul. As we journey through this landscape of thought, let us carry with us the wisdom of those who have pondered these questions before us. The words of physicist Richard Feynman echo through the ages, reminding us that the imagination of nature is far greater than the imagination of man. In this spirit, we are encouraged to embrace the mysteries of the universe with open hearts and minds, allowing the wonders of existence to unfold before us. In the world of quantum mechanics, the act of observation holds a transformative power, shaping the very essence of reality. As we continue to explore the philosophical implications of Schrödinger's cat, we find ourselves at the intersection of science and contemplation, where the boundaries of understanding blur and the mysteries of existence beckon us to delve deeper. Each inquiry invites us to embrace the unknown, to question our assumptions, and to explore the profound interconnectedness of all things. As we delve further into the philosophical implications of the observer effect, we are confronted with the question of reality itself. What does it mean for something to exist if its existence is contingent upon observation? This notion challenges our conventional understanding of the world, prompting us to consider the role of consciousness in shaping reality. The act of observing, in the realm of quantum mechanics, is not merely passive. It becomes an active engagement with the cosmos. Imagine a world where the mere act of witnessing an event alters its course. This idea resonates deeply within us, suggesting that our thoughts and intentions hold a power beyond what we can see. The philosopher and physicist Niels Bohr, a pivotal figure in the development of quantum theory, famously stated, "We are not talking about the world of our experience, but the world of quantum phenomena." His words remind us that the quantum realm operates under rules that defy traditional logic, inviting us to expand our perspectives and embrace the complexity of existence. The debate surrounding measurement and reality forms a rich tapestry of thought, with interpretations of quantum mechanics diverging into various philosophical schools. The Copenhagen interpretation posits that the act of measurement collapses a wave function, determining the state of a particle. This raises profound questions about the nature of reality. Does the universe exist independently of our observation, or is it a fluid construct shaped by our perceptions? In contrast, the many worlds interpretation suggests that every possible outcome of a quantum event actually occurs, each in its own separate universe. This interpretation evokes wonder and imagination, asking us to consider the infinite possibilities that arise from each choice we make. What if every decision we ponder branches into a myriad of realities, each one unfolding in a different direction? This notion can be both exhilarating and humbling, as it encourages us to reflect on the significance of our choices within the vast expanse of existence. The implications of these interpretations stretch beyond the confines of physics and seep into the realm of consciousness. If our observations shape reality, what does this mean for our understanding of the mind? The observer effect invites us to explore the relationship between consciousness and the physical world. As we ponder this connection, we may ask ourselves, are we passive witnesses to the unfolding of reality, or do we actively participate in its creation? The philosophical discourse surrounding Schrödinger's cat has captivated thinkers for generations, urging us to engage with the paradoxes that lie at the heart of quantum mechanics. The image of the cat, both alive and dead within its box, serves as a potent metaphor for the duality of existence. It embodies the tension between certainty and uncertainty, challenging us to confront our own beliefs about life and death, existence and non-existence. As we reflect on these themes, we may find ourselves drawn to the insights of Albert Einstein, who famously remarked, "Reality is merely an illusion, albeit a very persistent one." His words resonate deeply as we navigate the complexities of quantum mechanics, reminding us that our perceptions of reality are often shaped by our beliefs and experiences. In this light, the observer effect becomes a mirror reflecting our own consciousness, inviting us to explore the depths of our understanding. The allure of Schrödinger's cat lies not only in its scientific implications, but also in its ability to provoke profound philosophical inquiry. Each time we consider the fate of the cat, we are compelled to question the nature of existence itself. Are we simply observers in a deterministic universe, Or do we possess the agency to influence our reality? This inquiry leads us to the heart of our own existence, urging us to explore the interplay between observation, consciousness, and the universe at large. As we engage with these philosophical implications, we find ourselves immersed in a rich landscape of ideas that invites us to embrace the unknown. The mysteries of quantum mechanics challenge our assumptions, urging us to think beyond the confines of conventional wisdom. In the quiet moments of contemplation, we may experience a sense of peace, as if we are cradled in the embrace of the cosmos, navigating the vast seas of possibility that stretch before us. What lies beyond our current understanding? What wonders await those who dare to question and explore? The journey into these depths promises to be as enlightening as it is profound. As we grapple with the philosophical inquiries raised by Schrödinger's cat, we find ourselves not only pondering the nature of existence, but also recognizing how these concepts resonate beyond the realm of science. This paradox has woven its way into the fabric of popular culture, inspiring a myriad of interpretations across literature, film, and art. The allure of Schrödinger's cat extends into storytelling, shaping narratives that challenge our perceptions of reality and consciousness in captivating ways. As we shift our focus to the vibrant expressions of this idea in popular culture, we will uncover how these artistic representations reflect and influence our understanding of quantum mechanics, inviting all of us to engage with the mysteries of existence in new and imaginative contexts. Chapter 6: Schrödinger's cat in popular culture. The thought experiment known as Schrödinger's cat serves as a bridge, connecting the complex world of quantum mechanics to the broader canvas of human understanding. At its core, it raises significant questions about the nature of reality itself. Two primary interpretations of quantum mechanics engage with this paradox: the Copenhagen interpretation and the many worlds interpretation. The Copenhagen interpretation, championed by Niels Bohr and Werner Heisenberg, suggests that a quantum system remains in a state of superposition until it is observed. In this view, the act of measurement collapses the wave function, leading to a single outcome. Consider the cat in the box. Until someone opens the lid, the cat is both alive and dead, existing in a dual state. Yet, the many worlds interpretation, proposed by Hugh Everett III, offers a different perspective. It posits that all possible outcomes of quantum events actually occur, each in its own separate universe. In this scenario, one universe contains a living cat, while another holds a deceased one. The beauty of this interpretation lies in its challenge to our conventional understanding of reality. Which interpretation resonates more with you? Is it the singularity of observation or the vastness of infinite possibilities? Schrödinger's cat has permeated literature and film, becoming a metaphor that stretches far beyond its original scientific framing. In literature, authors have embraced this paradox to explore themes of uncertainty and duality. For instance, in the novel The Quantum Thief by Hannu Rajaniemi, the concept is woven into a narrative about identity and existence, reflecting the multifaceted nature of reality. Film directors have also found inspiration in the paradox. A notable example can be seen in the movie Coherence, where the storyline intricately plays with the idea of parallel realities, leading viewers to ponder the implications of choices and outcomes in a universe reminiscent of many worlds. The cat's dual existence becomes a narrative device to engage audiences in a deeper exploration of what could be, urging them to consider the ramifications of their own choices. In the realm of science fiction, Schrödinger's cat has significantly influenced storytelling. It serves as a catalyst, igniting the imaginations of writers and creators. The narrative possibilities are endless, Characters can exist in multiple states, traversing between realities and engaging with their alternate selves. This concept resonates with the human experience of decision-making and the infinite paths that lie ahead. Art and media have also embraced the cat's paradox. Artists have created works that visualize the abstract concepts of quantum mechanics, transforming complex ideas into tangible experiences. One striking piece is a painting that juxtaposes images of a cat in vibrant colors, existing both in light and shadow, embodying the essence of superposition. Such representations invite viewers to reflect on the nature of existence and the choices that shape our lives. As Schrödinger's cat continues to infiltrate popular culture, public perception of quantum mechanics has inevitably been influenced. The complexities of quantum theory, often shrouded in scientific jargon, become more accessible through films, books, and art. This simplification, while beneficial for sparking interest, can sometimes lead to misunderstandings. The cat, a charming and relatable character, serves as a gateway into discussions about the intricate world of quantum physics. Popular media often presents a dramatized version of quantum mechanics, which can be both enlightening and misleading. People may begin to see quantum physics as a collection of fantastical ideas rather than a robust scientific framework. Yet, the intrigue surrounding these concepts stimulates curiosity, encouraging an exploration of the underlying principles that govern our universe. In this way, Schrödinger's cat stands as both a symbol of scientific inquiry and a metaphor for the human condition. It invites us to ponder the delicate balance between observation and reality, while inspiring a generation of thinkers, creators, and dreamers to venture further into the depths of the unknown. So, what lessons can we draw from this curious feline? Perhaps it is the reminder that reality is not always as it appears, that the act of observation plays a crucial role in shaping our understanding of the world. Can the duality of Schrödinger's cat teach us to embrace uncertainty in our own lives, to acknowledge the myriad possibilities that exist beyond our immediate perception? In the ever-evolving landscape of culture, the concept of Schrödinger's cat continues to inspire and provoke thought, illuminating the profound connections between science, art, and the human experience. As we delve deeper into this fascinating intersection, we begin to appreciate the delicate threads that bind our understanding of reality, urging us to explore the infinite possibilities that lie ahead. As we journey further into the realms inspired by Schrödinger's cat, we encounter the intricate tapestry of interpretations of quantum mechanics. The many worlds interpretation and the Copenhagen interpretation stand as two prominent pillars of thought within the scientific community, each offering a unique lens through which to view reality. The Copenhagen interpretation, heralded by figures such as Niels Bohr, emphasizes the role of measurement, suggesting that reality emerges only upon observation. Bohr famously stated, "We are not talking about the nature of reality, but the nature of our knowledge of reality." This perspective invites us to consider how our perceptions shape the world around us, much like the curious cat that remains both alive and dead until we choose to glance inside the box. On the other hand, the many worlds interpretation, championed by Hugh Everett III, proposes a strikingly different narrative. In this view, every possible outcome of a quantum event actually occurs, branching into a multitude of parallel universes. Each universe represents a different outcome, leading to an infinite array of possibilities. Imagine a world where every decision you make spawns an alternate reality, where every choice diverges into unique paths. This perspective challenges our understanding of fate and free will, evoking questions about how our lives might unfold in the absence of a singular, definitive trajectory. As these interpretations shape the scientific discourse, they also permeate popular culture, weaving their way into literature and film. Authors and filmmakers alike have drawn inspiration from the paradox of Schrödinger's cat, utilizing it as a narrative device to explore themes of choice, consequence, and the nature of existence. In the realm of fiction, the cat's predicament serves as a metaphor for the uncertainty that defines our lives. Works like Dark on Netflix delve into the complexities of time travel and parallel universes, where characters grapple with the implications of their choices across multiple timelines. Each decision they make reverberates through the fabric of reality, echoing the essence of many worlds. Consider the profound impact of such narratives on our understanding of science fiction. In literature, Philip K. Dick often explored themes of reality and perception, painting vivid landscapes where the boundaries of existence blur. His story, The Man in the High Castle, invites readers to ponder alternate histories, much like the branches of possibilities suggested by many worlds. These tales invite us to reflect on the choices we make and how they shape not only our own lives, but also the world around us. The influence of Schrödinger's cat extends into the realm of visual art as well. Artists have utilized the concept to challenge perceptions of reality, crafting pieces that embody the duality inherent in quantum mechanics. The surrealist movement, with figures like Salvador Dali, invites viewers to question the nature of existence itself, blurring the lines between dream and reality. Imagine standing before an artwork that encapsulates the paradox of life and death, inviting contemplation of the unseen forces at play in our own lives. In contemporary media, the public's perception of quantum mechanics has been significantly shaped by the portrayal of these concepts in popular culture. Quantum physics, once an esoteric field reserved for the scholarly elite, has become a topic of intrigue for the general public. Films like Interstellar and What the Bleep Do We Know have introduced audiences to the wonders of quantum theory, often using Schrödinger's cat as a point of reference. These narratives serve to demystify complex scientific ideas, making them accessible and engaging for those unfamiliar with the intricacies of quantum mechanics. Yet, as enlightening as these portrayals can be, they can also lead to misconceptions. The allure of Schrödinger's cat may sometimes eclipse the profound nuances of the theories it represents. When the cat is depicted simply as a whimsical creature trapped in a box, the deeper implications of superposition and measurement risk being overshadowed. The challenge lies in striking a balance between captivating storytelling and scientific accuracy, ensuring that the essence of quantum mechanics is not lost in translation. As we delve deeper into the impact of Schrödinger's cat on popular culture, we encounter a fascinating interplay between science and art. The boundaries begin to blur as artists, writers, and filmmakers seek to capture the essence of quantum phenomena in their work. This interplay enriches our understanding of both fields, illuminating the ways in which creativity can inspire scientific inquiry and vice versa. What does this mean for our engagement with the universe? It invites us to embrace the unknown, to explore the multitude of possibilities that life has to offer. Just as Schrödinger's cat exists in a state of uncertainty, we too inhabit a world filled with infinite potential. As we ponder the implications of these quantum narratives, we are reminded that life itself is a grand experiment, filled with unpredictable outcomes and mysterious paths. In the landscape of popular culture, the stories we tell shape our understanding of reality, illuminating the intricate connections between science and the human experience. The concept of Schrödinger's cat serves as a bridge, linking the abstract realms of quantum mechanics with the tangible world we inhabit. It encourages us to question our perceptions, to seek deeper truths, and to embrace the beauty of uncertainty. As we explore the myriad representations of Schrödinger's cat, it becomes clear that this thought experiment transcends the confines of academia. It has found a home in the hearts and minds of those who seek to understand the unfathomable complexities of existence. Each reference, each portrayal, adds a layer to the conversation, inviting us to explore the rich tapestry of ideas that quantum mechanics inspires. So, how do we interpret the presence of Schrödinger's cat in our daily lives? Perhaps it is an invitation to acknowledge the dualities we encounter, to embrace the coexistence of possibility and reality. In a world where the unknown looms large, the lessons of quantum mechanics resonate deeply, reminding us that we are all participants in this grand experiment of existence. Artistic expressions often reflect the intricate dance between science and imagination. In literature, Schrödinger's cat has become a metaphor for uncertainty and choice, appearing in works that explore the nature of reality. Authors like Philip K. Dick have woven quantum themes into their narratives, inviting readers to question the fabric of their own existence. Dick once said, "Reality is that which, when you stop believing in it, doesn't go away." This echoes the essence of Schrödinger's thought experiment, urging us to reflect on how our beliefs shape our understanding of the universe. In film, the cat paradox often serves as a plot device, infusing stories with layers of meaning. Movies like Coherence play with the concept of branching realities, presenting a tableau of choices where each decision creates divergent paths. The viewer is left to ponder. What if our choices create parallel universes, each one a reflection of our potential? Such explorations captivate the imagination, making complex scientific ideas accessible and engaging. Visual artists, too, have embraced the enigmatic charm of Schrödinger's cat. Through paintings and installations, they evoke the sense of duality inherent in the quantum world. One can imagine a canvas split in two, one side depicting a vibrant, lively cat, and the other a still, lifeless form. This visual juxtaposition not only captures the essence of superposition, but also invites contemplation of life's delicate balance between existence and non-existence. As popular culture continues to evolve, our collective perception of quantum mechanics is undeniably influenced by these artistic interpretations. When we encounter Schrödinger's cat in various forms, do we not find ourselves reflecting on our own choices and uncertainties? In a world where science and art intertwine, we are reminded that understanding the complexities of the universe can be as much about feeling as it is about knowing. As we navigate the intricate interplay between art and science, it becomes clear that Schrödinger's cat serves as a profound lens through which we examine our own realities and choices. This rich metaphor not only permeates popular culture, but also echoes within the halls of modern physics, where the mysteries of quantum mechanics are being rigorously explored. With each artistic representation, we are drawn closer to the scientific inquiries that challenge our understanding of existence itself. In the next chapter, we will delve into the forefront of quantum research, uncovering how Schrödinger's cat continues to inspire contemporary discussions and innovations in fields ranging from computing to cryptography, illustrating the ever-evolving relationship between our imaginative interpretations and the scientific truths they seek to illuminate. Chapter 7: Analyzing Quantum Mechanics in Modern Physics. In the world of popular culture, Schrödinger's cat has become an emblem of the strange and enigmatic nature of quantum mechanics. It captivates the imagination, appearing in various forms across literature, film, and even art. The essence of the thought experiment, where a cat is simultaneously alive and dead depending on the observer, is frequently referenced in discussions about uncertainty and duality. The cat has made appearances in films, where its paradox becomes a metaphor for existential dilemmas. In literature, the concept is playfully dissected, often leading characters into philosophical quandaries. Artists, too, have been inspired, creating visual representations that evoke the duality inherent in Schrödinger's proposition. This popularization introduces the complexities of quantum mechanics to a broader audience, inviting people to ponder profound questions of existence. As we delve deeper into current research and advancements in quantum mechanics, the landscape reveals a realm teeming with potential. Scientists are continuously pushing the boundaries of our understanding, exploring phenomena that were once relegated to the theoretical. Quantum computing, for instance, stands at the forefront, with researchers harnessing the principles of superposition and entanglement to create computers that could solve problems beyond the reach of classical machines. One might wonder, how does this translate into tangible advancements? The answer lies in the development of qubits, the fundamental units of quantum information. Unlike classical bits, which can exist in one state at a time, qubits can occupy multiple states simultaneously. This unique property allows quantum computers to process vast amounts of information at unprecedented speeds. Companies and research institutions are racing to refine these technologies, and the implications for fields such as cryptography and optimization are profound. Schrödinger's cat continues to play a pivotal role in contemporary scientific discussions. It serves as a touchstone, reminding scientists and philosophers alike of the peculiarities that underpin reality. Its implications stretch beyond mere thought experiments, acting as a catalyst for debates on quantum interpretation and the nature of observation itself. The cat's existence in a state of superposition encourages researchers to explore the nuances of measurement and reality. As advancements unfold, we witness the emergence of experiments and technologies arising from quantum theory. Quantum cryptography is a particularly exciting field, utilizing the principles of entanglement to develop secure communication channels. Imagine a world where messages are transmitted with absolute security, impervious to eavesdroppers due to the fundamental nature of quantum mechanics. This dream is rapidly becoming a reality as scientists devise methods to secure data using quantum key distribution. The interdisciplinary applications of quantum mechanics stretch far beyond the confines of physics. Computing and cryptography are just the beginning. Fields such as medicine are also beginning to harness quantum principles. Quantum sensors, for instance, have the potential to revolutionize imaging technologies, enabling unprecedented levels of precision in medical diagnostics. Think about the implications of such technologies. What if we could detect diseases at their earliest stages with a device that operates on quantum principles? The potential for healing and understanding our bodies becomes a profound intersection of science and humanity. As we traverse the landscape of modern physics, the influence of Schrödinger's cat persists, not merely as a thought experiment, but as a guiding light in the exploration of quantum mechanics. Its essence encourages curiosity and wonder, reminding us that the universe is far more mysterious than we might have ever imagined. In this journey, we find ourselves at a crossroads of technology and philosophy, where the boundaries of understanding are constantly being redrawn. Scientists, inspired by the cat's paradox, continue to explore the implications of quantum mechanics, seeking to unravel the mysteries of existence itself. With each new discovery, the world of quantum mechanics becomes richer and more intricate, inviting us all to ponder the fundamental questions that lie at the heart of our reality. The adventure is only just beginning, and as we stand on the precipice of future advancements, the echoes of Schrödinger's cat resonate through the halls of modern physics, urging us to look deeper and dream bigger. As we delve deeper into the realm of quantum mechanics, the role of Schrödinger's cat extends far beyond a mere thought experiment. It has become a cornerstone of contemporary scientific discussions, embodying the paradoxes and complexities inherent within quantum theory. The image of the cat, both alive and dead, encapsulates a profound truth about the nature of reality itself. How can we reconcile such seemingly contradictory states? This question has become a catalyst for innovation and exploration in various scientific fields. Current research in quantum mechanics is teeming with excitement and new possibilities. Scientists today are probing the very foundations of quantum theory, undertaking experiments that push the boundaries of our understanding. One particularly fascinating area of exploration involves the phenomenon of quantum superposition, where particles can exist in multiple states at once. This is not merely a theoretical construct. Researchers have demonstrated superposition in various systems, from tiny particles to larger, more complex molecules. Imagine a particle existing in two places simultaneously, its wave function spreading out like ripples on a pond. This concept, once relegated to the realm of imagination, is now being tested in laboratories around the world. As physicist Richard Feynman once said, "If you think you understand quantum mechanics, you don't understand quantum mechanics." The elegance of this field lies in its ability to challenge our intuitions, urging us to reconsider what we know about the universe. In recent years, exciting advancements have emerged from the study of quantum entanglement, a phenomenon that occurs when particles become linked in such a way that the state of one instantly influences the state of another, regardless of the distance separating them. This strange connection has opened doors to potential applications in quantum computing and secure communication channels, where the principles of entanglement could be harnessed to create unbreakable encryption methods. Consider the implications of such technology. What would it mean for our current understanding of data security if communication could be rendered completely secure through the principles of quantum mechanics? It invites us to envision a world where our private information remains untouched by prying eyes, a reality once thought impossible. This notion echoes the sentiments of physicist Anton Zeilinger, who remarked, "The fundamental phenomena of quantum physics are not only fascinating, but also the key to new technologies." The interdisciplinary applications arising from quantum theory are vast and varied. Quantum computing, for instance, promises to revolutionize industries by solving complex problems that classical computers would take millennia to compute. By utilizing the principles of superposition and entanglement, quantum computers can process vast amounts of data simultaneously. Imagine a computer that doesn't just perform calculations, but rather explores multiple scenarios all at once, arriving at solutions that can change the course of fields ranging from medicine to finance. In the world of cryptography, the potential for quantum key distribution stands out as a remarkable advancement. By leveraging the principles of quantum mechanics, it is possible to create communication systems that are fundamentally secure against eavesdropping. The act of observing a quantum state alters its condition, ensuring that any attempt to intercept the communication would be immediately detectable. This could transform how we secure sensitive information, from governmental data to personal communications, marking a significant leap forward in safeguarding our digital lives. As we navigate these groundbreaking developments, it is essential to recognize the philosophical questions that arise alongside the scientific advancements. The nature of reality, as illuminated by quantum mechanics, continues to provoke deep contemplation. Schrödinger's cat serves as a reminder that our understanding of existence is fluid, shaped by the lens through which we observe it. The cat's duality compels us to confront the limitations of our perceptions, urging us to remain open to the mysteries that lie beyond our immediate comprehension. In this dynamic landscape, the role of thought experiments becomes increasingly significant. They serve as both a catalyst for inquiry and a means of grappling with the abstract concepts that quantum mechanics presents. By engaging with these mental exercises, scientists and philosophers alike can explore the implications of their findings, bridging the gap between theory and practice. As physicist Niels Bohr eloquently stated, "We cannot look upon the world as consisting of separate parts, but must understand it as an indivisible whole." One of the most intriguing aspects of modern quantum mechanics is how it intersects with other disciplines, creating a rich tapestry of interconnected knowledge. Fields such as biology are beginning to explore quantum effects, particularly in processes such as photosynthesis and avian navigation. Researchers are uncovering how quantum coherence may play a role in the efficiency of energy transfer in plants, suggesting that the underlying principles of quantum mechanics may influence the very fabric of life itself. Imagine the implications if these discoveries lead to a deeper understanding of biological processes. What if we could apply quantum mechanics to enhance our understanding of diseases or develop novel treatments? The possibilities are both exhilarating and humbling, as they remind us of the interconnectedness of all things, a theme that resonates deeply within the scientific community. As we stand at this intersection of technology, philosophy, and biology, it becomes clear that the influence of quantum mechanics will continue to expand. Scientists are not just probing the depths of theoretical concepts, they are translating these ideas into tangible technologies that can reshape our world. Quantum sensors, for example, are set to revolutionize how we measure and interact with our environment. They promise to enhance our capabilities in fields ranging from environmental monitoring to precision agriculture. Imagine a world where we can detect minute changes in our surroundings, from the slightest shifts in temperature to the faintest signals emitted by distant stars. Quantum sensors could provide insights into the subtle workings of nature, allowing us to understand patterns that were once invisible to us. This exploration of the quantum realm is not merely an academic endeavor. It is a journey that invites us all to reconsider our place within the universe. The echoes of Schrödinger's cat, with its profound implications for understanding reality, resonate through the halls of contemporary science. As we continue to unravel the mysteries of quantum mechanics, we are reminded that curiosity is the lifeblood of discovery. Each question leads to new avenues of exploration, urging us to probe deeper into the unknown. As we contemplate the future of quantum mechanics, the possibilities seem boundless. With each experiment, we inch closer to a fuller understanding of the universe and our role within it. It is a thrilling adventure, one that invites us to remain vigilant and engaged, ready to embrace the revelations that await us. The cat may be both alive and dead, but within its paradox lies the essence of inquiry itself, beckoning us to explore the depths of existence with wonder and humility. As we delve further into the realm of quantum mechanics, we find ourselves standing at the crossroads of discovery and innovation. The concept of superposition and the strange entanglements of particles are not just theoretical musings. They are the foundation upon which new technologies are being built. The ongoing research in quantum mechanics is paving the way for extraordinary advancements in fields such as computing and cryptography. Imagine a computer that harnesses the power of quantum bits, or qubits, which can exist in multiple states at once, unlike classical bits that are either 0 or 1. This ability allows quantum computers to solve complex problems at unprecedented speeds. As physicist David Deutsch once noted, quantum computation is a new way of thinking about how to harness the laws of physics to solve problems. This perspective invites us to envision a future where computational limits are pushed beyond our current understanding. In the realm of cryptography, quantum mechanics offers a promise of security that is unparalleled. By employing principles such as quantum key distribution, we can create communication channels that are fundamentally secure against eavesdropping. The beauty of this system lies in the fact that any attempt to intercept the quantum keys would alter the state of the system, thus revealing the presence of the intruder. It raises the question, what if our methods of securing information could be rendered unbreakable? This possibility is not merely a dream, but a tangible goal within our reach. Moreover, the interdisciplinary applications of quantum mechanics extend into various sectors, from medicine to materials science. Quantum technologies are being explored for their potential to revolutionize imaging techniques, allowing us to observe biological processes at the molecular level. Imagine witnessing the intricate dance of proteins as they interact within a living cell, revealing secrets that could lead to groundbreaking medical advances. As we stand on the brink of these innovations, it is vital to remember the philosophical implications of our findings. The role of Schrödinger's cat continues to spark discussions in contemporary scientific discourse. It serves as a poignant reminder of the complexities inherent in observation and measurement, challenging our perceptions of reality. How does our engagement with the quantum world shape our understanding of the fabric of existence itself? In the spirit of inquiry, we must ask ourselves, what lies ahead in the exploration of quantum mechanics? The future is brimming with potential, as researchers worldwide embark on experiments that challenge existing paradigms. In this uncharted territory, we are urged to maintain our curiosity and resilience, for each discovery is a stepping stone toward a deeper comprehension of the universe. The cat remains a symbol of this journey, embodying the dualities that define our quest for knowledge, inviting us to persist in our exploration of the profound mysteries that await discovery. As we contemplate the profound implications of quantum mechanics and its potential to reshape our understanding of reality, we are reminded of the critical role that thought experiments play in scientific inquiry. These imaginative explorations not only challenge our perceptions, but also pave the way for innovative breakthroughs. Schrödinger's cat, a pivotal example, serves as a bridge between theoretical musings and practical experimentation, inviting us to delve deeper into the philosophical underpinnings of our discoveries. In the following chapter, we will explore the significance of thought experiments in science, examining their historical context and the lasting impact they have had on our quest for knowledge. Join us as we unravel how these conceptual exercises continue to influence modern scientific thought and inspire future investigations. Chapter 8: The Role of Thought Experiments in Science. Thought experiments serve as a bridge between abstract reasoning and concrete scientific inquiry, allowing us to explore the depths of complex concepts without the need for physical experimentation. They are invaluable tools in the realm of science, offering a unique way to visualize and dissect hypothetical scenarios. By engaging the imagination, thought experiments invite us to consider possibilities that may not yet be testable or observable in the physical world. They encourage us to ask, what if, and to stretch the boundaries of our understanding. One of the most famous thought experiments is Schrödinger's cat, formulated by Erwin Schrödinger in the mid-20th century. This thought experiment elegantly illustrates the perplexing nature of quantum mechanics, particularly the phenomenon of superposition. By placing a cat in a box with a radioactive atom, a Geiger counter, and a poison vial, Schrödinger posed a scenario in which the cat could be both alive and dead until observed. This paradox not only sparked discussion about the nature of quantum states, but also highlighted the philosophical implications of observation itself. As Schrödinger himself stated, "I do not like the idea of the cat being alive and dead at the same time." Throughout history, thought experiments have played pivotal roles in broadening scientific horizons. Consider Galileo's use of mental imagery to challenge the prevailing notions of motion. By envisioning a ball rolling down an inclined plane, he laid the groundwork for classical physics. Similarly, Einstein's elevator thought experiment offered profound insights into the equivalence of gravity and acceleration, shaping the foundation of general relativity. These historical examples emphasize how thought experiments can ignite revolutionary ideas, helping scientists to question established norms and explore new realms of thought. The influence of Schrödinger's cat extends far beyond its original context. It has inspired countless thought experiments that challenge our understanding of reality and observation. Philosophers and scientists alike have engaged with this concept, each adding layers to its interpretation. For instance, the many worlds interpretation of quantum mechanics emerged from grappling with the implications of Schrödinger's cat, suggesting that each possible outcome of a quantum event actually occurs in its own branching universe. This idea compels us to ponder the nature of existence itself. What does it mean for reality if every decision creates a new universe? As we delve into these philosophical implications, we find ourselves balancing theory with practical experimentation. Thought experiments serve as a launching point for scientific inquiry, yet they require grounding in empirical evidence. The interplay between theoretical frameworks and tangible experiments is crucial in advancing our understanding of the universe. While thought experiments can spark innovative ideas, they also must be tested and validated through rigorous scientific methods. This delicate balance fosters a deeper comprehension of complex theories, while keeping them anchored in observable phenomena. In the realm of quantum mechanics, the questions raised by thought experiments like Schrödinger's cat linger in the air, urging us to explore further. How does the act of measurement influence the state of a system? The observer effect challenges our conception of reality, suggesting that we are not mere spectators, but active participants in shaping the outcome of quantum events. As physicist John Archibald Wheeler famously remarked, "We are not just passive observers of the universe, we are its creators." The legacy of thought experiments, especially in quantum physics, encourages us to embrace curiosity and imagination. They remind us that the boundaries of knowledge are not fixed, but rather dynamic, constantly evolving as we engage with profound questions. Each scenario invites us to ponder the interconnectedness of ideas, theories, and the very fabric of reality itself, weaving a narrative that inspires a sense of wonder. As we reflect on the role of thought experiments in science, we are reminded that they are not merely academic exercises. They are gateways to exploration, empowering us to challenge the status quo and envision new possibilities. Each thought experiment acts as a catalyst, urging us to question, to hypothesize, and ultimately, to expand our understanding of the universe and our place within it. What new questions will arise as we continue to ponder these profound ideas? What insights await us as we journey deeper into the realms of thought and imagination? The answers may lie just beyond the horizon, waiting for us to discover them. Delving into the philosophical implications of Schrödinger's cat leads us to consider the delicate interplay between observation and reality. Imagine for a moment the cat, nestled inside its box, existing in a state of ambiguity, the simultaneous potential of life and death, a paradox that disturbs our intuitive understanding of existence. This thought experiment, while seemingly whimsical, reveals a profound truth about the nature of quantum mechanics. It challenges our perception of certainty. Erwin Schrödinger, the mind behind this provocative scenario, intended to highlight the absurdity of applying quantum mechanics to everyday objects. Yet, the paradox encapsulated within the box has sparked rich discussions that reach far beyond mere scientific inquiry. As physicist Richard Feynman aptly put it, if you think you understand quantum mechanics, you don't understand quantum mechanics. This admission serves as a reminder that the complexities of the universe often elude our comprehension, urging us to embrace uncertainty rather than shy away from it. Consider how this uncertainty extends into various scientific fields. The role of thought experiments has been pivotal across disciplines, from philosophy to theoretical physics. They serve not just as tools for illustration, but as instruments for innovation, pushing the boundaries of what we deem possible. Historical examples, such as Galileo's inclined plane, prompt us to explore fundamental principles without the constraints of physical experimentation. By imagining scenarios, Galileo was able to articulate the laws of motion long before they were empirically validated. In the same vein, we can reflect on the thought experiment of Maxwell's demon, conceived by James Clerk Maxwell in the 19th century. This hypothetical creature, capable of sorting molecules by their speed, challenges the second law of thermodynamics and invites us to consider the nature of entropy and information. What if this demon could exist? How would it alter our understanding of thermodynamic principles? Such questions ignite the imaginations of scientists and philosophers alike, manifesting in discussions that shape the evolution of scientific thought. As we traverse the landscape of thought experiments, it becomes clear that their importance in scientific inquiry cannot be overstated. They allow us to explore the ramifications of theories without the immediate need for physical experimentation. In doing so, they expand our conceptual frameworks and offer insights that might otherwise remain obscured. Schrödinger's cat stands as a beacon of this intellectual exploration. Its legacy has inspired a slew of thought experiments that probe the essence of reality and our understanding of the universe. The many worlds interpretation, for instance, posits that every quantum event branches into multiple realities, each representing a different outcome. This notion invites us to consider the vastness of existence itself. Can we fathom a universe where every choice leads to a different path? What stories lie in those alternate realities? This intricate dance between theory and practical experimentation is essential. While thought experiments stimulate the mind and provoke discussion, it is through empirical research that we ground our theories in observable phenomena. The tension between these two realms, abstract thought and tangible evidence, creates a fertile ground for scientific advancement. The development of quantum mechanics exemplifies this delicate balance. Early theorists, grappling with the implications of their findings, often relied on thought experiments to navigate uncharted waters. Niels Bohr and Albert Einstein engaged in profound debates centered around the implications of quantum theory, each positing thought experiments to explore their stances. In their intellectual sparring, they laid the foundation for much of modern physics, illustrating how dialogue rooted in imaginative thought can yield substantial advancements. As we ponder the essence of thought experiments, we might ask ourselves, how do they shape the future of scientific inquiry? Are they merely stepping stones to empirical validation, Or do they hold intrinsic value in the scientific process? The answer is both nuanced and enlightening. While experimental validation is crucial, the theoretical groundwork laid by thought experiments fosters a culture of inquiry that encourages scientists to push boundaries and explore the unknown. In contemporary discussions, thought experiments continue to serve as vital tools for scientists and philosophers alike. They invite us to grapple with ethical implications, such as in the realm of artificial intelligence and bioethics. Consider the trolley problem, a thought experiment that forces us to confront moral dilemmas in decision-making processes. It challenges us to weigh the value of individual life against the greater good, prompting discussions that shape policies and ethical standards in technology and medicine. Imagine a world where these philosophical inquiries guide the development of technology. What ethical frameworks might emerge from our reflections? How might these frameworks influence the trajectory of scientific progress? It is through the lens of thought experiments that we can envision a future where moral considerations are woven into the very fabric of scientific advancement. As we reflect on the significance of thought experiments, we recognize that they are not confined to the dusty realms of academia. They echo through our daily lives, prompting us to question our beliefs and assumptions. Each hypothetical scenario encourages us to engage with the world around us, fostering a mindset of curiosity and exploration. The interplay between thought and reality remains a source of wonder. As physicist Albert Einstein once said, "Imagination is more important than knowledge, for knowledge is limited, whereas imagination embraces the entire world, stimulating progress, giving birth to evolution." This sentiment captures the essence of thought experiments. They are vessels of imagination that drive scientific evolution. In the spirit of exploration, we might consider the implications of quantum mechanics on our understanding of consciousness. The observer effect suggests that our very act of observation influences the state of a system, raising profound questions about the nature of reality. Are we merely passive observers, or do we play an active role in shaping the universe? This inquiry intertwines with the philosophical discourse surrounding the nature of consciousness itself, urging us to reevaluate our understanding of existence. As we immerse ourselves in this dialogue, we can appreciate the power of thought experiments in illuminating the complexities of our universe. They beckon us to consider the unobservable, to challenge our assumptions, and to embrace the uncertainty that accompanies exploration. In navigating this terrain, we are reminded of the words of physicist and philosopher David Deutsch. "The fabric of reality is made of information." This statement encapsulates the essence of thought experiments, as they weave together strands of inquiry, philosophy, and science into a coherent narrative. Each thought experiment acts as a lens, refracting the light of knowledge and revealing the intricacies of existence. As we journey deeper into the realms of thought and imagination, we invite the questions that lie ahead. How will the evolving landscape of science continue to be shaped by our reflections and inquiries? What new horizons await us as we engage with the profound questions of our existence? The tapestry of knowledge is ever expanding, and it is through our curiosity that we will continue to weave the narrative of understanding. As we stand at the intersection of thought and reality, the questions inspired by our exploration of thought experiments beckon us to delve deeper into the intricate layers of scientific understanding. In particular, Schrödinger's famous cat serves as a powerful lens through which we can examine the misconceptions that often cloud our grasp of quantum mechanics. By unraveling the common misunderstandings surrounding this thought experiment, we can clarify the distinctions between theoretical constructs and tangible reality. As we embark on this journey, we will illuminate the importance of education in demystifying quantum concepts, ensuring that our curiosity transforms into a clearer comprehension of the universe's complexities. With each inquiry, we edge closer to not only understanding Schrödinger's cat, but also the broader implications of quantum theory in our everyday lives. Chapter 9: Misunderstandings and Misconceptions of Schrödinger's cat. In the realm of quantum mechanics, the thought experiment known as Schrödinger's cat has sparked both fascination and confusion. It serves as a gateway into the complexities of quantum superposition, a phenomenon where particles exist in multiple states at once until observed. Modern experiments continue to explore this captivating concept, shedding light on the nature of reality and the very fabric of the universe. Picture a delicate system where a cat, in a sealed box, simultaneously resides in a state of life and death. The fate of the cat hinges on an unpredictable quantum event, showcasing superposition in a vivid, albeit macabre, scenario. This paradox has led to various experiments attempting to recreate such conditions. For instance, scientists have conducted tests with photons and atoms, observing their dual states. These experiments reveal that particles can exist in a blend of possibilities, only to settle into a single state upon measurement. Yet, what are the common misconceptions surrounding this thought experiment? One prevalent misunderstanding is that Schrödinger's cat implies that the cat is literally alive and dead at the same time. This interpretation oversimplifies the nuances of quantum mechanics. In reality, the cat represents a complex interplay between quantum states and measurement. The cat is not in two states simultaneously in a tangible sense. Rather, it highlights our limited grasp of quantum systems. Moreover, there is a tendency to conflate the theoretical aspects of quantum mechanics with observable reality. Quantum theory provides a mathematical framework to describe behaviors at subatomic levels, but it does not dictate our everyday experiences. The notion of superposition is a theoretical construct that challenges our classical understanding, not a direct representation of the world we inhabit. Addressing these oversimplifications is crucial. Many individuals approach quantum mechanics with preconceived notions shaped by popular culture or anecdotal interpretations. The allure of Schrödinger's cat often leads to the dismissal of the intricate mathematics and principles that underpin quantum theory. As physicist Richard Feynman famously stated, "If you think you understand quantum mechanics, you don't understand quantum mechanics." This serves as a reminder of the depth and complexity of the field, urging us to delve deeper rather than settle for superficial explanations. The importance of education in quantum mechanics cannot be overstated. It is vital for aspiring scientists and curious minds alike to engage with the material as it is, rather than as they wish it to be. Educational initiatives that foster a deeper understanding of quantum concepts can help bridge the gap between fascination and comprehension. By cultivating an environment where questions are encouraged, we can illuminate the shadows of misunderstanding that often accompany this enigmatic subject. Imagine a classroom filled with eager students, each grappling with the implications of quantum mechanics. They ponder the nature of reality, the role of observation, and the paradoxes that challenge their intuitive understanding. Through guided discussions and hands-on experiments, they begin to appreciate the beauty of quantum phenomena, recognizing that the universe operates on principles beyond the confines of classical logic. As we navigate through these discussions, we must also remind ourselves that the world of quantum mechanics is not merely a collection of abstract thoughts, but a field grounded in rigorous experimentation. The experiments that explore quantum superposition are not only designed to validate theory, but also to expand our capacity for understanding. They are a testament to human curiosity and the relentless pursuit of knowledge. In this light, we see that the dialogue surrounding Schrödinger's cat is more than a mere philosophical debate. It is a crucial exploration of the unknown. Each misinterpretation presents an opportunity for growth, inviting us to refine our understanding and embrace the complexities of the universe. The journey through quantum mechanics is one of continuous learning, where each revelation opens the door to new questions and possibilities. As we reflect on these themes, we can appreciate the rich tapestry of ideas that quantum mechanics presents. It invites us to reconsider our perceptions of reality, challenging us to think beyond conventional boundaries. The journey is not simply about answers. It is about cultivating a mindset that embraces inquiry and wonder. This chapter, rich with the intricate details of quantum theory, serves as a reminder that every exploration, no matter how perplexing, can lead to enlightenment. As we continue to unravel the mysteries of Schrödinger's cat and quantum mechanics, we find ourselves on the precipice of new discoveries, ready to embrace the unknown with open hearts and inquisitive minds. Modern experiments have delved deeply into the enigmatic world of quantum superposition, shedding light on the very principles that underpin Schrödinger's cat. One fascinating realm of experimentation lies within the manipulation of photons, the fundamental particles of light. Researchers have conducted experiments where photons are placed in superposition states, existing simultaneously in multiple paths. Imagine a beam of light that, instead of traveling a single route, splits into two pathways and can be detected in both places at once, until it is observed. This phenomenon has profound implications for our understanding of reality and the nature of existence itself. As physicist Anton Zeilinger once articulated, what we observe is not nature itself, but nature exposed to our method of questioning. This highlights the delicate balance between theory and observation. In essence, the act of measurement collapses the potentialities of the quantum world into a single outcome. This interplay between observation and reality beckons us to consider the implications of our own choices and perceptions. Are we mere spectators in a preordained universe, or do our observations actively shape the landscape of reality? Common misconceptions often arise from this complex relationship between reality and theory. Many assume that Schrödinger's cat suggests that the cat is literally both alive and dead until observed. However, this interpretation oversimplifies the concept. The cat does not exist in a halfway state. Rather, it serves as a metaphor for the superposition of quantum states that particles can embody. The cat's fate reflects the uncertainty inherent in quantum mechanics, illustrating the fundamental principle that until a measurement is made, the system exists in all possible configurations. This oversimplification can lead to a misunderstanding of quantum principles. It is essential to clarify that while quantum systems can exist in superposition, this does not imply that macroscopic objects, like cats, behave in the same manner. The cat is not a quantum particle. It is a macroscopic entity, and classical mechanics governs its existence. In this way, Schrödinger's thought experiment illuminates the gulf between the quantum and the classical worlds, rather than conflating them. Furthermore, it is crucial to distinguish between the theoretical framework of quantum mechanics and the tangible reality we experience daily. Quantum theory provides a mathematical model that predicts probabilities, yet it does not dictate the outcomes of specific events in the classical realm. The cat's paradox, therefore, serves as a bridge, prompting us to explore the boundaries between what is theoretically possible and what is practically observable. It encourages a deeper inquiry into the nature of reality itself, inviting us to question our assumptions and embrace the unknown. As we ponder the implications of these ideas, we might ask ourselves, what is the role of education in quantum mechanics? The need for clarity and understanding in the teaching of quantum concepts cannot be overstated. As physicist Richard Feynman famously stated, if you can't explain it simply, you don't understand it well enough. This highlights the importance of breaking down complex theories into accessible narratives that resonate with students and the public alike. Education in quantum mechanics must strive to engage curiosity, foster inquiry, and illuminate the beauty of these intricate concepts. By creating a foundation of understanding, we empower individuals to explore the wonders of the universe, transforming confusion into fascination. Imagine a classroom where students are encouraged to ask questions, to explore the nuances of quantum behavior through hands-on experiments, and to marvel at the peculiarities of the subatomic world. This nurturing environment can cultivate a generation of thinkers who are not only knowledgeable, but also passionate about the mysteries of existence. Modern educational initiatives are beginning to embrace these principles, utilizing interactive simulations and visual aids to bring quantum concepts to life. By providing immersive experiences, students can witness the strange behavior of particles, developing a personal connection to the subject matter. Such innovative approaches can demystify the complexities of quantum mechanics and inspire a sense of wonder. In this ongoing journey, we must also recognize the importance of interdisciplinary collaboration. The dialogue between physics and philosophy, art, and even literature can enrich our understanding of quantum mechanics. This cross-pollination of ideas fosters a broader perspective, allowing us to approach the mysteries of the universe from multiple angles. As we consider the implications of Schrödinger's cat, we find ourselves at the intersection of science, philosophy, and culture, each contributing to a more holistic comprehension of reality. As we delve deeper into the implications of quantum superposition, we also encounter the phenomenon of quantum decoherence. This process describes how quantum systems lose their superposition states when they interact with their environments. Imagine a delicate butterfly, its wings shimmering in the sunlight, only to be caught in a sudden gust of wind, scattering its radiance. In the same way, a quantum system can collapse into a definite state when observed or influenced by external factors. This realization helps to clarify the boundary between the quantum and classical worlds, reinforcing the notion that observation is not merely passive, but actively shapes the outcome of events. Decoherence serves as a bridge to understanding why we do not observe macroscopic superpositions in our daily lives. In our classical world, the myriad interactions with our environment effectively cause quantum states to lose their coherence, resulting in the observable reality we experience. This understanding helps to demystify the apparent contradictions often associated with quantum phenomena, reinforcing the notion that the quantum world, while perplexing, is governed by principles that can be understood with patience and inquiry. As we contemplate the journey of understanding quantum mechanics, we must also appreciate the crucial role of ongoing research and experimentation. Scientists continue to push the boundaries of knowledge, conducting experiments that challenge our perceptions and deepen our insights into the quantum realm. For instance, advances in quantum computing hold the promise of harnessing superposition and entanglement to revolutionize technology. Imagine a world where computers operate on principles that blur the lines between classical and quantum processing, unlocking unprecedented capabilities for problem-solving and creativity. As we reflect on the rich interplay of ideas that surround Schrödinger's cat and its implications for quantum mechanics, we find ourselves enmeshed in a web of inquiry that transcends the boundaries of traditional science. Each question leads to new explorations. Each revelation opens doors to further understanding. In this ever-expanding landscape, we are invited to embrace the mysteries of existence, to wonder at the fabric of reality, and to cherish the pursuit of knowledge that defines our humanity. In this light, we can begin to see that our misunderstandings and misconceptions about quantum mechanics are not merely obstacles. They are opportunities for growth and exploration. Each misinterpretation encourages us to delve deeper, to refine our understanding, and to embrace the beauty of inquiry. The dialogue surrounding Schrödinger's cat invites us to reconsider our perceptions of reality, challenging us to think beyond conventional boundaries. As we continue to unravel the mysteries of the quantum world, we remain poised on the brink of discovery, eager to explore the unknown with open hearts and inquisitive minds. As we stand at the convergence of understanding and curiosity, the journey through the enigmatic landscape of Schrödinger's cat has illuminated the intricate relationship between observation and reality. With each misconception dismantled, we find ourselves not just reflecting on past interpretations, but also eagerly anticipating the future that quantum mechanics holds. Emerging theories and groundbreaking experiments promise to redefine our grasp of the universe, leaving us on the cusp of new discoveries. In the next chapter, we will delve into these exciting frontiers, exploring the potential breakthroughs and their profound implications for technology and society. Join us as we venture into the future of quantum mechanics, where the questions we pose today may shape the answers of tomorrow. Chapter 10: The Future of Quantum Mechanics and Experiments. As we gaze into the future of quantum mechanics, the echoes of Erwin Schrödinger's insights resonate deeply within the scientific community. His visionary thoughts have inspired a multitude of directions in quantum physics, igniting curiosity and fostering innovation. The very essence of Schrödinger's ideas invites us to explore realms where the familiar laws of classical physics bend and twist into the extraordinary. Picture a world where particles exist in states of possibility, a concept that has transcended mere thought and begun to shape experimental endeavors. Emerging theories in quantum physics are painting a vivid picture of what lies ahead. One such theory revolves around the idea of quantum gravity, seeking to merge the principles of quantum mechanics with those of general relativity. This potential breakthrough could unravel the mysteries of black holes and the origins of the universe, challenging our understanding of time and space. As physicist Carlo Rovelli noted, the universe is not a collection of objects, but a web of interactions. This perspective encourages us to envision a universe not as static, but as a dynamic interplay of forces and particles, each participating in an intricate dance of existence. Ongoing experiments continue to probe the depths of Schrödinger's cat concept and superposition, where the boundaries of what we perceive as reality blur. Researchers at the forefront are employing advanced techniques to manipulate superposition states, creating conditions where particles can exist in multiple states simultaneously. Imagine a single photon, embodying both a wave and a particle, traversing paths that intertwine and separate, only to reveal its nature upon observation. Such experiments challenge our intuitions and beckon us to reconsider the very fabric of reality. In the heart of this quantum exploration lies the profound impact of these discoveries on technology and society. Quantum mechanics has already begun to revolutionize fields such as computing, cryptography, and telecommunications. Quantum computers, harnessing the power of superposition and entanglement, promise to solve problems that are currently insurmountable for classical computers. As physicist David Deutsch articulated, the fundamental reason why quantum computers will be more powerful than classical computers is that they can perform many calculations simultaneously. Picture a future where complex simulations and optimizations are executed in mere moments, reshaping industries and enhancing our understanding of the universe. The societal implications of quantum mechanics extend beyond technology, influencing our philosophical and ethical frameworks. As we unlock the secrets of the quantum world, we are confronted with questions that probe the essence of reality and consciousness. What does it mean to observe? How does our perception shape the world around us? These inquiries echo the sentiments of physicist Niels Bohr, who famously stated, "We must be clear that when it comes to atoms, language can be used only as in poetry." The blending of science and philosophy invites a holistic understanding, urging us to embrace the uncertainties that accompany our quest for knowledge. As we peer into the horizon of quantum research, speculations arise regarding the next frontiers that await our exploration. One tantalizing possibility is the development of quantum networks, where entangled particles can be linked over vast distances, creating a new paradigm for secure communication. This concept embodies the potential to redefine privacy and information transfer, enabling instantaneous connections that defy the constraints of classical physics. Envision a world where information flows seamlessly, where the act of sharing transcends geographical boundaries, and where trust is embedded in the very structure of communication. Moreover, as we delve deeper into the quantum realm, we may uncover the elusive nature of dark matter and dark energy. These enigmatic components of our universe remain largely uncharted territories, but quantum theories could provide insights that bridge the gap between the known and the unknown. Imagine unlocking the secrets of the cosmos, understanding the forces that govern its expansion, and perhaps even glimpsing the potential for interstellar travel through the manipulation of quantum states. The journey into the future of quantum mechanics is not merely a scientific endeavor. It is a voyage of imagination and possibility. As we stand on the brink of discovery, we are reminded of the words of physicist Richard Feynman, who said, "The imagination of nature is far, far greater than the imagination of man." This sentiment encapsulates the essence of scientific inquiry, inviting us to embrace the unknown and explore the depths of our universe. In this unfolding narrative of quantum mechanics, the legacy of Schrödinger and his thought experiment continues to inspire new generations of scientists and thinkers. The mysteries of superposition and entanglement remain fertile ground for exploration, inviting us to question, to wonder, and to seek answers that may redefine our understanding of reality. As we imagine the future, we find ourselves not as passive observers, but as active participants in a grand cosmic symphony, where each note resonates with the potential for discovery. The interplay between theory and experimentation is vital to this journey. As scientists push the boundaries of knowledge, they are met with challenges that require innovative approaches and collaborative efforts. The spirit of inquiry thrives in laboratories around the world, where teams of researchers are dedicated to unraveling the complexities of quantum systems. Each experiment is a step toward a deeper understanding, a stitch in the ever-evolving fabric of quantum physics. With each advancement, we inch closer to answering the profound questions that linger in the minds of scholars and enthusiasts alike. What lies beyond our current understanding? How can we harness the principles of quantum mechanics to address global challenges? The future is bright with possibilities, beckoning us to explore the intersections of science, technology, and human experience. In this age of discovery, we find ourselves at a crossroads, where the potential for breakthroughs in quantum research is matched only by the philosophical implications of our findings. How will our understanding of the quantum world shape our perception of consciousness, free will, and the nature of existence? These inquiries are not merely academic. They touch upon the very core of what it means to be human in a universe governed by the mysterious laws of quantum mechanics. As we traverse this landscape of exploration, the stories of those who have paved the way for these advancements are woven into the narrative of our journey. The visionaries, the pioneers, and the dreamers who dared to question the status quo have laid the groundwork for future discoveries. Their contributions remind us that the pursuit of knowledge is a collective endeavor, one that requires courage, curiosity, and collaboration. In this chapter of quantum mechanics, we stand on the threshold of the unknown, ready to embrace the challenges and opportunities that lie ahead. The future holds the promise of new discoveries, innovative technologies, and profound insights that will shape our understanding of the universe and our place within it. As we look forward, let us carry the spirit of inquiry that has driven humanity for centuries, fostering a sense of wonder and excitement for the journey yet to come. Emerging theories in quantum physics, inspired by the enigmatic work of Schrödinger, hold the promise of transforming our understanding of reality. One such theory is the concept of quantum gravity, which seeks to reconcile the principles of quantum mechanics with those of general relativity. Imagine a fabric of space-time that is not merely a stage for events to unfold, but a dynamic entity influenced by the very particles and fields that populate it. As physicists delve deeper into this interplay, they aspire to unlock the secrets of black holes, the Big Bang, and the fundamental nature of the universe itself. The quest for a theory of everything, a unifying framework that encapsulates all physical phenomena, continues to inspire awe and aspiration. At the heart of this pursuit are ongoing experiments that challenge our perception of the quantum world. The phenomenon of superposition, famously illustrated by Schrödinger's cat, has taken on new dimensions in contemporary research. Scientists are exploring the boundaries of superposition in macroscopic systems, pushing the limits of quantum coherence. Picture a delicate state where an object exists in multiple positions simultaneously, defying our classical intuition. Such experiments not only illuminate the peculiarities of quantum behavior, but also pave the way for advancements in quantum computing and information technology. As we consider the impact of quantum mechanics on society, we are compelled to reflect on its transformative potential. Quantum technology is no longer confined to the realm of theoretical discourse. It is increasingly becoming a part of our everyday lives. The advent of quantum computers promises to revolutionize fields ranging from cryptography to drug discovery, allowing us to solve complex problems at unprecedented speeds. As physicist John Preskill aptly stated, quantum computing is the ultimate tool for solving problems that are intractable for classical computers. Can you envision a world where our most pressing challenges, from climate change to disease eradication, are addressed through the powers of quantum algorithms? Yet, with great potential comes great responsibility. The integration of quantum technology into our social fabric raises ethical questions and concerns. How will we safeguard the integrity of information in a world where quantum encryption can render traditional security measures obsolete? As we tread carefully into this new era, we must cultivate a dialogue that encompasses not only the scientific community, but also society at large. The implications of our discoveries extend beyond the laboratory. They touch the very essence of trust, privacy, and autonomy in the digital age. As we peer into the horizon of quantum research, the next frontiers beckon with tantalizing prospects. The exploration of quantum entanglement, that peculiar connection between particles that transcends space and time, holds immense potential for technology and communication. Imagine a future where entangled particles form the backbone of instantaneous communication networks, rendering distances irrelevant. This dream is not far-fetched. It is a possibility grounded in ongoing research that pushes the boundaries of our understanding of connectivity. As physicist Anton Zeilinger remarked, entanglement is a phenomenon that cannot be explained by classical physics. It is a glimpse into the mysterious interconnectedness of our universe. What lies beyond our current capabilities? The future of quantum mechanics invites us to consider the implications of quantum biology, a burgeoning field that examines the role of quantum phenomena in biological processes. Could the principles of quantum mechanics be responsible for the efficiency of photosynthesis or the navigation abilities of birds? As researchers embark on this journey, they uncover the intricate dance of particles at play within living organisms. The implications of such discoveries could reshape our understanding of life itself, revealing connections between quantum mechanics and the very essence of biological existence. In this landscape of possibility, the spirit of inquiry remains our guiding light. The legacy of visionaries such as Schrödinger serves as a reminder that curiosity must be nurtured and celebrated. As we explore the uncharted territories of quantum mechanics, let us remain open to the unexpected, embracing the wonder and mystery of the universe. Each experiment, each theory, and each question propels us forward, illuminating the path toward greater understanding and discovery. As we navigate this intricate web of knowledge, let us remember that every breakthrough is built upon the foundations laid by those who dared to dream. The future of quantum mechanics is not merely a scientific endeavor. It is a collective journey that intertwines the fates of humanity and the cosmos. With each step we take, we draw closer to unraveling the profound mysteries that lie at the heart of existence, inviting us to ponder our place within this vast and wondrous universe. What revelations await us in the depths of quantum reality? The answers may yet surprise us, leading us to realms of understanding previously thought to be the realm of imagination. As we stand on the brink of these extraordinary possibilities, the future of quantum mechanics unfolds like a tapestry woven with threads of curiosity and imagination. The journey we have embarked upon not only enhances our technological landscape, but also deepens our connection to the natural world and our understanding of life itself. Each discovery, each question, serves as a stepping stone toward a more profound comprehension of the universe, inviting us to embrace the unknown with open minds and hearts. The path ahead may be uncertain, yet it is illuminated by the brilliance of those who have come before us and the potential that lies within our collective inquiry. In the dance of particles and the mysteries of entanglement, we find not just answers, but a renewed sense of wonder, reminding us that the quest for knowledge is as boundless as the cosmos itself.